This is a basic introduction course to PDF analysis. You don't have to know anything about PDF. We will do it with step-by-step exercises, really simple exercises, but they will still present you with challenges. In fact, when you're quite familiar with analyzing PDFs, you will find this workshop boring. It is not designed for people who have quite some knowledge, skills analyzing PDFs. This is just a really simple intro course. Let's say PDF for Dummies. Oh, how we are on the front of starting the virtual machine. Who is already running his virtual machine? No?
Copying.
Still copying. Okay. Sorry?
Copying is fast for me, but booting up the system was so slow.
Yeah.
Can you tell us the instructions again?
Root and tour. The credentials for backtrack, eh? Is that what you're asking?
No, the instructions you just
Okay.
displayed on the screen.
This one.
Like this one, exactly.
Now, the reason that I work with a DVD with a virtual machine is that you can take this this workshop home. So I'm not doing it in the cloud, because otherwise, when the workshop here is over, you cannot do any of the exercises anymore. But here, with your copy, you can, if you want to, work further on the exercises, because you will see that in one of the folders that you are copying, there is a file with all the solutions to all the exercises. Okay? No, DVD you come to pick up at the front, my DVD.
This workshop, right?
It's with a laptop, yeah. If you have no laptop, it will be really boring for you.
Plaatsen zijn voor diegenen die een workshop echt willen deelnemen, hè? Dat er nog plaatsen zijn om
Ik
te
weet het,
zitten.
maar meestal willen ze dat niet.
Ah, oké.
Ik kwam eigenlijk zoeken of dat er hier drinken was.
Maar ik zal drinken gaan halen.
Ja. So the DVD I'm speaking about is not the DVD you find in your bag, in your black hat bag. It's the DVD that is on the front of the desk here, one I created especially. start with the first exercise. Let me point. Yeah. There is one USB stick. I believe it's in the front here. Do you still have? Okay, yeah. You will have to wait for that. Now, just for your info, I've also made several YouTube movies about each of the exercises. And here is an example. You can find them on my website. If you go on my website, you can find links to those YouTube exercises. With my own tools. Is there already one virtual machine running in the room? Yes, one, two. Good. So then log in with the credentials, root and tour. And if you have another keyboard than QWERTY, look at it in the README text files. You can see how you can change that keyboard. Now the thing I can also tell you that this, for the analysis of the PDF files here, we will be working with my tools, PDF ID and PDF parsers. Those are two tools, Python tools that I developed. It was a design choice to use Python so that you can run the analysis tools on many different platforms, that you are not restricted to a couple of platforms. For DVDs here. So for example, I can also run my PDF parser tools on my Nokia phone, which comes with the installable Python interpreter. The exercise files you will be getting, so there are 20 exercises if I'm not mistaken. I've built them completely myself. So there is no risk whatsoever that malware is hiding inside those PDF files. I've created the PDF files themselves with my own tools, not with Adobe Reader, Adobe Acrobat or something like that. With my own Python tools, I created the PDF files. And then there are a couple of PDF files that contain JavaScript. Again, I've developed myself the JavaScript. And then there is one with shellcode. Again, I developed the shellcode from scratch. So I have complete control over all the exercises. I know there is no malware in it. But still, some of the antivirus products might flag it as malware. And that is because, for example, in one of the exercises, I'm using a function that contains a vulnerability, util.printf, and that is well known by antivirus companies, and they will flag any PDF file that just contains that string. Thank you.
Question.
Yeah.
Can you show checksums of files since we copied them off USB media? So
From which files?
check. Well, for instance, the backtrack image.
Backtrack, okay.
I guess the
Are you having an issue with that zip file?
Not yet.
Not yet.
At least.
Maybe if I just calculate the MD5, that will be faster. Yeah, that will be faster. Okay, so show of hands, how many running VMwares? Yeah, not that much, 3 or 4. Starting, okay. Okay, yeah. The USB stick is here, if anybody needs one. Whoa, sorry. I have a bit of a cold, sorry about that. I didn't expect that effect. Ah yeah, the guy there just took it.
No. It has the same.
Yeah, thank you. So you may bring back the DVDs if you're done with them. Okay, there is a checksum. Thank you. So the way we will work through this workshop is by doing as many exercises as we can. Like I already told, I have complete control over every PDF file inside the exercises. So there is no malware in those PDF files.
You have the USB stick?
No, USB stick is over there.
I'll pass you.
If you have encountered zipped exercise files, you have to unzip them with the password infected. That's a standard password that is used for samples. I'm just doing that for in the case you are working this this workshop on a Windows laptop, because you could also do it on Windows. And if you're on Windows with an antivirus product, it could trigger on some of the PDF files. And then the thing we are going to do is first have a look at the exercise with PDF ID. PDF ID is my triage tool. I mean that tool will help you to decide if the file you are looking at is probably malicious or probably benign. And if it is probably malicious, then we will continue with more detailed analysis with PDF parser. PDF ID is rather simple. It cannot do any decompression or stuff like that. And that is also by design, so that it would be very difficult to exploit PDF ID, because it's just such a simple tool. And that tool, PDF ID, is also running on the VirusTotal side. So if you submit a malicious PDF document to VirusTotal, you will not only see all the results from the different antivirus vendors, their products telling you if they detected malware or not, but at the bottom you will also see the read port of PDF ID, which will help you to decide if it's likely that that PDF file is malicious or not. Okay? Now, for the very first exercise, we don't need a tool at all. It's very simple PDF file I've made, pure ASCII. You can just look at it with Notepad. And that's what we are going to do. So if your virtual machine is still booting, go to the files directory. So that's the other directory that was on the DVD. The files directory, and open up exercises. And here I have the first exercise, X001, which I open with my PDF reader, and it just displays Hello World. That's all it does. Now let's open that with a simple editor. And here you have the text that makes up that PDF file. And I'm going to walk you through this. So first of all, a PDF file needs a header. %PDF minus. Normally, it's the first line in the PDF document, but the PDF official documentation states that it can be in the first 1,000 bytes. Okay? That is something that malware authors will also use as a kind of obfuscation, to put it somewhere else. But normally, all normal PDF files, benign PDF files, have the header at the beginning. 1.1 is the version of the PDF language, not the PDF reader, but the PDF language. At the bottom, we have a trailer. %% end of file. And that is actually how a PDF reader will start to analyze a PDF file for rendering it. It will look at the beginning to see if it's dealing with a PDF file, and then it will straight on move to the end of the file. Because at the end of the file, you will find a crossref table. So you have end of file here. PDF parser then goes looking to start crossref just in front of the end of file. Start crossref 644. And now, if I jump to position 644 in that file, I will be at the crossref header. So it's a position, it's a location of information that the parser needs to understand the PDF file. So let's go to 644. That failed. Okay. 644, you see we are now here, crossref. That is the crossref table. Now a PDF file is built up of different objects. We will see them soon. And the crossref table contains the position of each object in the file. This first entry here is a mandatory entry. It's always like that. It's a default entry. 7 indicates that we are working with 7 objects. There are 7 objects inside the PDF file. The first real PDF object is located at position 12. So I can go to position 12 and find here that object. Objects start with a major and a minor number, keyword object, and then end with keyword end object. And all objects are built up like that. I can go through them. So this is how a PDF reader understands PDF and is able to render it. Looks at the beginning of the file, okay, it's PDF, goes to the end, looks for the crossref, finds the crossref, and then finds all of the objects. A PDF document has a tree structure. So there is a root element where all the other objects descend from. That root element is indicated in the trailer. Following the crossref table, you have a trailer, and here you have the reference to the root. The root object is object 1, 0, so object number 1, minor number 0. The R is a reference to indicate that it's a linker reference. Okay, so now the PDF parser, for example Adobe Reader, knows that it has to look at object 1 because that will be the root of the tree that builds up the PDF document. So let us sorry. Let us take a look. Most attribute information of objects is contained in a dictionary. A dictionary starts with smaller, smaller sign and ends with greater, greater sign. So this delimitates a dictionary. And then you have key value pairs each time. So this object is a catalog, which is normal. The root object of a PDF is a catalog object. It contains outlines, and the outlines refer to object 2. And it also contains pages. Pages can be found in object 3. So let's have a look at object 3, which interests us. So 3 is a set of pages. There is only one page, the count is 1. And which object contains that page? You can find that under kids, 4. 4 minor 0 reference. That is the reference to object 4. So object 4 is our page, which you can find here. Type page, parent, media box, that's the size. And here, interesting, the content. So what will be displayed on the page? Content, 5. So now you know the trick. You go have a look at object 5. And here you have it. This is a special object because it contains a stream. Up till now, the objects we saw only contained dictionaries. But this one contains a dictionary and a stream, that is to say data. Stream objects are again identified like normal objects, objects and end objects, but then they also have the keyword stream and end stream. This is a programming language that is designed to draw on pages. This instruction here will draw the text "Hello World" in the left corner, upper corner of the page. That's what it's doing. So BT stands for begin text. Here we select a font, which is a TF font, size 24. So that is the font we are going to use to write. Then we go to absolute location 100, 700, which is in the upper left corner because numbering starts down left, 100. And then TG, we type the text between brackets here, hello world. Okay? So that is, simply put, how a PDF object has its internal structure and how it renders a page. Now, such a PDF file, you will not find them in the wild because we will have, for example, compression and other stuff that makes it much more difficult to read. And that is why we need tools to analyze them. Okay? Now, I want you to run PDF ID on this first exercise and see what we get. Who is still waiting for his VMware machine to boot? Oh, that's good. So, more than half of the class has a VMware running. That's great. So let me go to my VMware machine too.
Version on the we're going to use about for PDF ID newer than on your website.
Yes, that is true. On the CD it's newer, but today I'm releasing a new version. And that version is still newer than the one you have on the DVDs. The major changes in PDF ID and PDF parser that I'm releasing today is that now you have support for Python 3. It will also run on Python 3. I've fixed a couple of bugs, and I also included a couple of features suggested by my readers. But I have still other features in the pipeline. So let's run PDF ID on that first exercise. Let me move.
Can you make the font larger?
I think I can do that if I'm going to X window. Let me do that. And then start up a console with a larger font there. Because here I was just in character mode, I don't think I can change the size of the font there. How is that for you? And now? It's okay now?
Yes.
Okay. No problem. So PDF ID. Yeah, sorry. I'm not on my Belgian keyboard. Okay. So the PDF tools are stored in the root folder and the exercises are stored in the exercise folder. And that's the result you get when you run it. It will first check the header to make sure that it is a PDF file. And if it has a valid PDF header, it will count several instances of keywords. Like, for example, a number of objects and end objects. Just count them, streams, stuff like that. And we will see later on that stuff like JS and JavaScript is important for analyzing malicious PDF files. Okay. So that's how you run PDF ID, PDF parser, same. You start it and then you select your exercise. And here it will parse it. I will go through explaining the output of the parser here once we go into exercises. But for example, you remember that the text hello world was contained in object 5. Okay? So with PDF parser, I can say that I only want to analyze object 5, like that. And then it analyzes it for you. You see that it contains a stream, but it doesn't display the stream. You can add an option to display the stream, but we will do that later on. Okay, so that is how you analyze PDF files, how you start analyzing them. Here, with that first exercise, we could do it with Notepad, because there was no compression or obfuscation or anything like that. Okay. Now move into the second exercise. Okay. So start that and try to find out what's happening there. The second exercise is actually exactly the same as the first exercise. Let me open that PDF file for you. You see that PDF file just display hello world. That's what it does, nothing more. But if you open that file with an editor, you see the structure I explained. Okay, but then if you run up in object 5, you see some binary code, some binary strings, and not the hello text. Okay. So that is what you actually will find in normal PDF files. The stream has been compressed, and that's why you cannot read it. Okay? You cannot read it with Notepad because it is compressed. But my tool, PDF Parser, allows you to decompress that stream. So that's something you have to find out with my tool. So with PDF Parser, you can select object 5, like I showed you, -05. And then there is an option to decompress the content and render it. Now, remember that, well, you have to be aware that Adobe uses the following terminology. Any transform that is applied to a stream, for example, compression, is called a filter. And the filter, you can see here for object 5, we have a filter. The filter that has been applied to the content of the stream is called flayed decode. So that gives you an indication that the stream has been compressed and that you have to decompress it. If you look at the options of PDF Parser, you will see that there is an option to apply filters. And by applying filters, it will decompress flayed decode compression. Okay. Did we manage to extract that text, hello world, with PDF parser? Yeah? Okay, let me show you then. So let me just run PDF ID for good measure on that second exercise. And I get the same result, no surprise here. Then PDF parser on exercise 2. And we know that we are in object 5, so I'm just going to print out object 5. If I don't specify that, it will print out everything it finds in a PDF document. But here, what did I do wrong? Oh yeah, it's PDF. I didn't provide it the correct file name.
Sorry for interrupting you again.
Yeah, no problem.
I need to install VirtualBox, which is not part of this DVD, is it?
No VirtualBox. I think VirtualBox is on the DVD.
Or maybe it is?
No, that is the
Or is it under files?
the virtual machine itself.
Okay, then VirtualBox, if it's under files,
It's
then
in tools. Where did you copy tools?
there were not tools, there were files.
Files, yeah.
Here's files.
Files. And in
Oh,
no,
one
sorry,
of these
files. And in files you have tools.
Oh, okay.
And in tools you have VirtualBox and VMware Player. If you don't have VirtualBox and neither VMware Player on your machine, install VMware Player. It will be easier.
Okay,
Okay?
VMware Player.
Yeah. So it tells us we have a stream here that is compressed, flaky code. To decompress that, we apply a filter. We tell him to apply the filters, -F. And then you get as output our text, hello world. Okay, so that is why you need some tools to analyze PDF files, because there will be compression and obfuscation. Okay, exercise 3. Move on to that. Again, exercise 3 shows just hello world on the page, nothing more. But inside there is something special again, and I want you to find out what. So start exercise 3 and let me know what's special about exercise 3 compared to exercise 2. Yeah.
You can come here.
There are 2 places in front.
There are still places left.
Sorry, I'm going to sneeze. Well. Why? And now? No. Okay, so what difference did you notice between exercise 3 and 2? Yeah?
Yeah, it's somehow ASCII encoded.
Yeah. There is a difference in the filter that is applied. So let's have a look with PDF parser. Again, we are working on object 5. Sorry, that has to be exercise 3. And now you see that not only do I have Flate decode, like in the first exercise, so exercise 2, but I also have ASCII hex decode. The thing is that with filters in object streams for PDF documents, you can use more than one filter. And that is something that malware authors will use a lot to obfuscate their code. The thing that is done here is that first the file is compressed with Flate and then in fact I can show you that. Let me open exercise 3 with a normal editor. Okay, and you see that the stream here is just hex code. So, first of all, the original stream is compressed with Flate decode, and then the result of Flate decode is compressed again, well, transformed with ASCII hex decode. If you have to recover the original data, you have to apply the ASCII hex decode first, followed by Flate decode. Yeah? You can do that with PDF parser. There is nothing special to it. You just tell it to apply filters. It will itself discover that there are more than one filter and apply all the filters in the necessary sequence. And then again you get the hello world text. Okay? Now this is a trick that is used, for example, in the Metasploit modules that generate PDF files, that they use different filtering methods, compression methods, and that by that they can encode the same stream in many different formats. Because, for example, you could encode first your stream in hex code and then in Flate, so really compress it. The thing about encoding it in hex code in the PDF language is that it is allowed to add white space. So you may add spaces, new lines between your hex characters. And when you do that at random, you will end up with a completely different compressed image. So just by working with the white space in there, that's one way of generating all kinds of new PDF compression streams, and by that way hope to evade detection systems like antivirus. Yeah?
So how many different filters are there?
There are about 7. And a couple of them are for images, like JPEG. So you cannot really use them for JPEG because JPEG is a lossy compression format. So if you decompress it, you will lose information. But some of the image filters have parameters that allow you to specify zero loss. So in theory, I have not done that yet, but in theory you could use that filter, image filter compression, say zero loss, and compress your data. And then when you decompress it, you have the original back without any difference. Okay, I think now we move into JavaScript. Yep. Exercise 4. Exercise 4, take a look at that exercise and you will discover JavaScript in it. Why are we going to? Is that before the coffee break? Okay, so in 10 minutes we have a coffee break. I will be staying here. So if you have questions or if you want to move on, no problem. My wife here gave me a bottle of vodka, so I don't need any coffee. So let me open that exercise. So it's a JavaScript example, but you don't see any JavaScript in action. Okay, we will see why. Analyze the file first with PDF ID. Okay. So analyzing it with PDF ID, same data. Here now, we have one page, and it contains JavaScript, JS and JavaScript. This is how PDF ID has recognized the keywords JS and JavaScript and warns you about the presence of JavaScript, because JavaScript will be used a lot of times to exploit directly with JavaScript vulnerabilities, or else exploit something else, like rendering, like JBig2 decode vulnerability, but still use JavaScript to make a heap spray, to fill up the memory with shellcode that will execute when the vulnerability in the JBig2 decode decoder triggers. Okay? Popular malware in the wild, popular PDF malware in the wild always uses JavaScript. Now, PDF parser, we know that this document contains JavaScript because PDF ID told us so. PDF parser has a search option, -S, and we can search for JavaScript. And then you give it the exercise. Okay. And it's found it. Object 7 is an action object. Its action is to execute JavaScript, and the JavaScript it has to execute is here, app alert. So just display a message box with the text hello from PDF JavaScript. Okay? That's what it does. But remember, I opened this file with my PDF reader who supports JavaScript, but the JavaScript message box, pop-up box was not displayed. Okay? Any idea why we didn't see that PDF message box? I mean JavaScript message box? No, JavaScript is enabled on my thing. There is no open action, that's it. So, not only can you embed JavaScript into PDF files and also Flash, but you also have to tell the PDF rendering engine, PDF reader, with the proper codes in PDF that it should execute the code. So it's not only necessary to put the JavaScript code in there, but you also have to tell it to execute the code. And there are different ways to execute. For example, what we are going to see in the next exercise is that the JavaScript executes when the document's opened, an open action. This is an action. We will encode an open action that will trigger this action at opening of the document. But you can have other actions. For example, we can have an action that when the reader displays page 10, that at that moment JavaScript is executed. Okay? So take a look at exercise 5. You will see that it also contains JavaScript. Start with PDF ID, and you will see a difference there, and analyze that difference with PDF parser. You see, exercise 5 here displays the message box. Okay, result of PDF ID on exercise 5, again, JavaScript, JS, but a new keyword that has been detected, open action. So let's look for open action with PDF parser. We search for open action with PDF parser. Okay. And here you see it. In our first object, the root object, it's a catalog. Not only have we outlines and pages, but now we also have an open action. An action to be taken when the PDF document is opened. The open action is defined in object 7. So look at object 7. And no surprise there, object 7 is our JavaScript. Okay? So it's not only that you have to find JavaScript, but you also have to find a trigger to the JavaScript to understand how the malicious PDF document is working. Okay, the break has started now. If you want to go grab a coffee, you can. If you want to stay here and continue working on an exercise, it's okay. Now, just a question, do you need a 30-minute break, or is 15 minutes enough? Is everybody fine with a 15-minute break? Yeah, no complaints? Okay, then I see you here at 11:30, and then we go on. You see here? This is an action, type action. The action we will take is execute JavaScript, and the JavaScript to be executed is contained in object 8. So you have a look at object 8. And there it is compressed. If you decompress it, so apply the filter, you will see the app alert, so the message box. Okay? Okay, do exercise 7 now. Also JavaScript, but something special. Run PDF ID on exercise 7. And again, we have obfuscated JavaScript names, open action, so it contains JavaScript. Let's go look for it. So you do that again with PDF parser, searching for the string JavaScript. And tell me what you find. Okay. Do you have the same result? Yeah. Okay, what's that? Thing is, in malicious PDF documents, the criminals will not make your life easy by just using JavaScript that you can read without any problem. They will obfuscate the JavaScript to make it very difficult to understand what the JavaScript is actually doing, so that you have a hard time reverse engineering and finding out what they are trying to achieve. Now, I'm not going to present real obfuscation because that is so difficult that it falls outside of the scope of this workshop. I cannot explain and discuss that kind of obfuscation in just a small workshop. It would take several days. But the thing that I have done is add some simple obfuscation elements to JavaScript here so that you have a feel of obfuscated JavaScript and how you have to deal with it. Okay? Do you have any idea what is going on here in this JavaScript? Someone an idea?
Is it a heap spray?
Sorry?
Is it a heap spray?
Sorry, I can't understand.
Heap spray.
No, not an heap spray.
Building up a character at a time.
Yeah, it is building up a string. What it is actually doing is building up a string character by character. And then that string that has been built up is evaluated. So it is run as a JavaScript instruction. And that is something you will find in most obfuscated JavaScript files. That is that a string is built up via a complex procedure, not a simple one like here, but a complex procedure builds up the string, maybe sometimes more than one string, then combination and execution. So let me show you another option. That's what the command that I used to have the JavaScript. If you add option -w, that stands for raw, you will have the exact output like it is in the compressed file. So it makes it a bit more readable. See? We start with a string that we assign character code 97. And then to that string we add character code 112, and so on, until we arrive at the end, and then we evaluate that string. So evaluating a string in JavaScript just means execute a string. Okay? Now, you could do that by hand, looking that up, but we are going to use automated techniques. I have a JavaScript interpreter that can run that code. It's a SpiderMonkey from Firefox, but it's a special version of SpiderMonkey. I've modified that version of SpiderMonkey to help us with analyzing JavaScript. One of the changes, for example, in this implementation of SpiderMonkey is that each time the eval function is called, SpiderMonkey will write a text file with the arguments that go inside eval, so that you can see what is actually sent to the eval command for execution. Okay, so first, with PDF parser, we extract the JavaScript and do some cleanup. So here, let's store that in JavaScript file 7. You remove that metadata here in the beginning until you keep the pure JavaScript. Okay, that's my JavaScript. So I've extracted the JavaScript, the obfuscated JavaScript from the PDF document, and now I will execute it dynamically with my modified SpiderMonkey, which is JS. You have that on your machine, JS. You pass it exercise 7 JavaScript, not the PDF, but the JavaScript, and you run it, and you get an error, which is a really informative error. App is not defined. It means that the JavaScript tried to do something with the app object, and the app object is not defined in SpiderMonkey. So that's good news. It means that we managed to deobfuscate and execute the code. Now, if you look in the directory, you will see 2 eval files there. These have been written by SpiderMonkey at the moment that eval was called. There are 2 eval files. One in the case that the string that is passed on to eval is ASCII code. And the second one is in the case that the string passed on to eval is Unicode, because that is something we do not know. You can pass on Unicode, you can pass on ASCII code. So the simple trick I did is to write out the 2 of them. The first one is the ASCII code, so let's have a look at that first one. And there you have your deobfuscated JavaScript. Again, it is app alert to display the message box. Okay? So if you have obfuscated JavaScript, the first thing you can try is to extract the JavaScript and run it to a JavaScript interpreter like SpiderMonkey and see what you end up with. Remember, we had the error that app didn't exist, and that's because of the command here. The command starts with app object and takes the alert method. App object is not defined in SpiderMonkey, so you get an error. Okay? Now take a look at exercise 8. It's also obfuscation, but a step further. And once you manage to extract the JavaScript, let me know what you see as a problem to analyze that JavaScript. Is this workshop fast-paced enough? Is fast enough? Mm-hmm. Okay. So let me first clean up my environment. Erase the eval files and the JavaScript from exercise 7. Okay. PDF ID on exercise 8. And we have obfuscated JavaScript name with an open action. So let's search for.
But in the end,
Sorry?
this is the same as the last one.
So let's look for JavaScript in exercise 8. It is contained in object 8. And it is compressed. So let's filter it, and here we have it. And let's write it to a file. So raw output, that's raw output, and send it to a file, exercise 8, JavaScript. You can erase the metadata here at the beginning. And here again is our obfuscated code. It's the same structure. You recognize the structure. We build up a string, one character at a time. And in the end, we evaluate that string that we built one character at a time. Now, and there is an added complexity, difficulty here, and it is also something that you will often find in malicious PDF files. That is that we are referring to some internal data element of the PDF reader. So, app.viewerVersions, that gives us the version number of the PDF reader. For example, on Adobe 9, it would be 921. Okay? And malware authors will often use that. One reason is to only target PDF readers for which you have an exploit, and don't do anything else on those for which they have no exploit. So for example, if they have an exploit on Adobe Reader 9 but not on 10, they will use that test in their JavaScript to test and only target the correct reader so that they don't give alerts out to people who have the wrong PDF reader. Another thing is that they can have different payloads. A payload, an exploit for version 8, another one different for version 9. And then they will use this test here, read the version and decide which payload do I have to execute. That's another way. But the thing is that they also take those values, those data, to make obfuscation more difficult to deobfuscate. Because here, you cannot run that deobfuscation, JavaScript, through SpiderMonkey to obtain the deobfuscated code, because SpiderMonkey doesn't know what app viewer is. Okay? So app viewer version, that is an object that you find in Adobe Reader, in the JavaScript interpreter of Adobe Reader, but it is not an object you find into SpiderMonkey. So how do you solve that? There are several ways to solve it. First of all, you can add that object, that app object, with the proper method to SpiderMonkey. It requires adding a bit of C code, but that is not something we will do here. The thing we will do here is that we will assume that we are targeting Adobe Reader 9. And I know that because I've built it for Adobe Reader 9. And so we will replace here that mat floor, this is expression, by the number 9. Okay? Because app.viewerVersion will give something like 9.2, and then with the function matFloor, we leave the fractions behind. We only take the integer, which is 9. Okay? So you edit this file and you replace the matFloor app viewer version expression by number 9. And then you run it to JavaScript, so SpiderMonkey. Should you have forgotten in SpiderMonkey, in VI, how to do this? You go to the command line, so colon, from 1 till the end, $. I want to do a substitution. of mat floor, no, sorry, that's lowercase, up viewer version and I replace that, the substitution, with 9. Okay, that's a VI command if you use VI. And pattern not found, what is my error? I I put in dot too many, sorry. Okay. So and I've substituted that expression that SpiderMonkey doesn't know by an expression we know, the value 9. Another way is to build that feature into SpiderMonkey, yeah? But that is not the goal here of our workshop, to program in C.
So is it possible to show how you do that, the change for line?
Yeah. So let me just save it and do it at the top of the line. So in VI, I type colon to enter in command line mode. For all the file lines, I want to do, sorry, no, there's $, $1 to $, so all the lines. I want to do a substitution. So, and I type in here the element I want to search for, so that is mat, and so on. Close the substitution, and then type the new value I want, and then again close, and then enter. And now you can execute that piece of JavaScript with SpiderMonkey. Again, we get the same error. Up is not defined, which is a good sign. Let's take a look at the eval arguments. Yep, and we get again up alert here. So this is what makes analyzing PDF documents outside of their context more difficult, because they will sometimes use, well, often use elements from the reader they want to target in their obfuscation, so that it makes for you more difficult to deobfuscate. Okay. Another trick they do can be found in exercise 9. So take a look at exercise 9 and tell me, again, there is JavaScript in it. Tell me where the JavaScript is found and how it is executed. Because that is another way of obfuscation. I'm just going to highlight a couple of simple obfuscation. In real world, it's much more complex than that. But we don't have enough time to cover all those cases. Yep.
If it's not hard for you, could you write the commands that you follow to analyze this pinded document?
It is. I've done that. So if you go in the folder files, there's a document folder, and you will find this file with solutions. And that contains all the commands to solve the exercises. And there are also YouTube videos of these exercises that I've made. You can see the them to how to do it. So, what about that next exercise? What did you discover? What information do you get from PDF ID on exercise 9? So we have JavaScript, open action, looks standard to me. Okay. So let's go hunting for the JavaScript. JavaScript is in object 9. Let's take a look at object 9. It's compressed, so filter object 9. And now we get this. Let me put it on the top of the screen. That is the actual JavaScript. This JavaScript here, you have no idea to tell me what it does. There is no way for you to understand what this does if you don't have the complete context. The thing is that we are working with annotations. In PDF documents, when you read PDF documents, you can add annotations depending on your reader you use. Like post-it stickers when you write some text. So you can add annotations to existing PDF files. We are using these annotations here. You see? We start for the annotations. And then we retrieve one annotation, the first one, 0. So we get that annotation and we evaluate it. So this means that the JavaScript is hiding in an annotation. The JavaScript is no longer in object 9, but in object 9 is a small piece of generic JavaScript code that will get its malicious JavaScript from another part of the document, which is hidden in an annotation. And so you have now to find that annotation. One way you can try is to search for annote. So let's do that. Instead of Java, I search for anno. And here you see that object 7 is an annotation, the type annotation, and that it is referencing object 10. So we have an annotation, and the text of the annotation is in object 10. Let's have a look at object 10. You don't see anything because it's in a stream. Minus W, no, minus F, W. Okay. So to view the annotation, you have to apply the filter and then raw mode to see it clearly. And this is an annotation that contains JavaScript. So that is a third technique that will be used to obfuscate Java code. That is that you will find Java code, JavaScript code, but the actual malicious code is not there. It's stored somewhere else in the file, in an annotation. And that's where you need to find it. Well, looking for annotations. Okay, so that was exercise 9. I'm going to stop now with obfuscation exercises. This was just to give you a small idea of what's possible with obfuscation. It can go much further, much more difficult, but I'm not going to have that in this workshop. Okay? Move on to exercise 10. There is something interesting too. Run exercise 10 to PDF ID and tell me what you get. So if you look at object 10, sorry, you open the JavaScript 10, exercise 10, open it, you see that we have JavaScript running, our classic dialog box here. But now, if you run PDF ID, you don't see any JavaScript. There's no JavaScript here. So, how is it possible? What do you see that you didn't see before in this output?
Start,
This one here, object stream. This is one. Start xref, that points to the trailer. That's normal. Object stream here, one. It's the first time we encounter this one. Now, the PDF language has been evolving for a long time, and what happens with such large sets of knowledge is that it becomes more and more complex, and sometimes complexity is even added when it's not really necessary. But the thing here is that we have detected an object stream inside the PDF file. And what is an object stream? An object stream is an object with a stream, and that stream contains other objects. Okay? So an object stream is an object with a stream, but inside that stream there are other objects. And if that stream is compressed, you will not recognize the content of the objects. Okay? And that is a way that malware authors will try to mislead you to hide their JavaScript inside the compressed stream of that object stream. So I propose that you get that object stream, decompress it, and look inside to see what you can find in that object stream. So with PDF parser, you can search for that object stream. And it's in exercise 10. Object STM, it is. And there you have it, object 1 is an object stream. It contains 6 objects, and 6 means that there are 6 objects inside that object stream. It is compressed, And the first object in the stream can be found at position 32. So let's apply a filter since it is compressed. Sorry. That was the wrong place to put that option. And here you can see the different objects. Here, that's an array that indicates the different elements to be found inside the object stream. So we have six objects: object 2, object 3, object 4, object 5, object 6, object 7. The 0, 68, 99 is a location in the stream where that object starts. And then we start here with our objects. This is our first object, which has an open action. Here we have JavaScript. Here we have JS.
It's better readable if you add the option W.
Yeah, we can do that. So here now you see the different objects. You see the keywords op, obg, and endobg are not present. It is just a dictionary. Okay, and here you have JavaScript. Now, you can take this output and pipe it into PDF-ID so that PDF-ID analyzes this. The only thing is that this is not a valid PDF file because it has no header. So you have to pass an option to PDF-ID to force it to analyze the file. And we will do that. Let me just move to the top of the screen here. So a pipe into PDF-ID with option force. And then you get the results and you see that it finds the JavaScript and the open action. So that is something important to know. If with PDF-ID you identify an object stream, OBJSTM, then you have with PDF parser to decompress that stream and feed it into PDF-ID to see if it contains JavaScript or not. Yeah.
All the objects you extracted from the dictionary and from the original document, you don't see valid cross-reference tables or valid trailers?
No, indeed.
So that means it's not necessary to have those things?
They are present in the beginning. Remember that I told you the numbers? I don't know if it was here. Yeah. This is a simple crossref table. You see? Object 2, position 0. Object 3, position 68.
Would it be possible to confiscate even further and make in these list of
No.
lines?
No, you can use a classic obfuscation, but luckily for us, you cannot put an object stream inside an object stream. That's not possible. Okay, there's only one level. So important to know, if with PDF-ID you see object stream 1 or more, then you have to use PDF parser to decompress them and pass them again in PDF-ID to see what is hiding inside that. You will find object streams in benign documents too. Object stream is not necessarily an indication that we are dealing with a malicious file. It is used to compress our objects and gain space. Okay. Now analyze the JavaScript of object sorry, exercise 11.
Should we unzip this first, this exercise 11?
Sorry?
But we should unzip this first because it's a zip file, the exercise 11.
Oh yeah, sorry, if it's still zipped, yeah, unzip it. Sorry. Let me see here on my machine. Yep, it's a zip file. The reason it is a zip file is that it contains JavaScript with a call to util.printf. And that is a non-vulnerable file function. And many antivirus programs will detect it and erase it. So the password is infected, lowercase. With PDF ID, you see it contains JavaScript and an open action. So let's find the JavaScript with PDF parser. Okay. So if you search for JavaScript in the unzipped PDF file 11, you will get this. This is an exploit for Adobe Reader 8.1, I believe. If you want to try it out, I have also copied a vulnerable version of Adobe Reader on the files, on the DVDs. So you have that with you. If you want to try that out, install that vulnerable version of PDF Reader, Adobe Reader, in a virtual machine, for example. Open this, and you will see that it will crash. Okay?
But it's fixed in newer versions, so most users should have newer versions.
Yeah, of course. Yeah, it's fixed in new versions. It's that's one of the reasons why I took it. It's an old bug from 2008, if I'm not mistaken. It's an old bug, so it's quite unlikely that it would cause problems with browsers with readers you have. Okay? So the thing to trigger the bug is rather simple. We define a very long number, and then we will pretty print that long number with a lot of leading zeros as a float. And once you do that, you will have a crash. That is to say that EIP, the instruction pointer, will end up somewhere else where you don't expect it. It's around hexadecimal 32, 32, 32, 32. And it will try to execute code at location 32, 32, 32, 32. Okay? This simple bug makes that Adobe Reader tries to execute code at 32, 32, 32, 32. Okay? But there is nothing there. There is no memory there, so Adobe Reader will just crash. Access violation, and there's a crash. How will script kiddies try to exploit this? Well, they will try to make sure that at location 32, 32, 32, 32, there is code, there is something that can be executed, their malicious code. Okay, and that's what we are going to see in the next exercise, so you can take a look at exercise 12. Yeah. You have to unzip it too, sorry. PDF ID on exercise 12. We have JavaScript, we have an open action, nothing else. So search for JavaScript. Okay, we have it here. This is a complete exploit with shellcode. You will not, again, find it as clear as here, because it will be obfuscated. We'll first have to undo the JavaScript obfuscation to arrive to this result. But now that we have already touched upon obfuscation, I'm not going to introduce it in the other exercises. Makes for more difficult understanding. So just keeping it simple. So exercise 11 contains this. It triggers a bug. Code execution is passed to a address in memory where there is nothing, so we have a crash. This here will try to put our code in that location. So, and that is a heap spray that we will be going to use. That's the simplest way to achieve this. First of all, here we have our shellcode. When you see an escape with encoding of Unicode characters here, you can be sure that we are actually converting that Unicode string into shellcode. So a program, an independent program that can act and change our environment. So that is shellcode in its Unicode representation that with the unescape command will be converted to real machine code instructions, shellcode. Designed, of course, to run in a Windows environment. We are doing it here for Windows. So we have our shellcode this way. JavaScript allows us to store shellcode in a variable. The problem now is to put that shellcode at the correct location. There is no way in JavaScript for PDF to tell it, okay, I want to write at that location in memory. There is no function to do that. The workaround, which is pretty crude, it's brute force crude, is to fill up the memory with our shellcode, and that is the heap spray. That is what is going on here. We create a large block of 1,200 elements, and we assign it with our shellcode. So we put our shellcode all over the place inside the heap. Okay? Now, once our shellcode is everywhere inside the heap, and we trigger then our vulnerability in util printf with this code, it will jump to location 32, 32, 32, 32, and then what will happen then? Will our shellcode execute or not? Yeah, any idea? Hands up who thinks it will execute. Okay? Hands up who think it will not execute. Nobody? And okay, people who think maybe it will execute. Yeah? Okay, well, that is actually the correct answer. It will maybe execute. Because the thing is, with many programs, shellcode is the same, they have an entry point. You have to start the program, in our example here, at the beginning of our code. If you start running the program somewhere in the middle, it will fail, it will not work. You have to start that at the entry point. And if you fill up your memory with the shellcode, you still have no guarantee that if you jump to 32, 32, 32, 32, that is the beginning of the shellcode. So that's a problem. And they also have a kind of brute force workaround for that, and that is called an obslet. An obslet is also a shellcode program, but a shellcode program that does actually nothing. If you start running that obslet shellcode, the first instruction will do nothing, and it will move on to the next instruction. And that instruction will do nothing, and move on, and so on. It will go all the way down to the program, just doing nothing. But that is interesting in our case, because those instructions are only 1 byte long, and since the program does nothing at all, you can start it anywhere. Since the program does nothing, okay, you can start it in the beginning, you can start it in the middle, and it will run, and have done nothing. So the result is the same. Okay, so now
So why building a chain of big blocks and not one single big block with knobs and
for fragmentation of the memory, you are not sure that you can fill. So we are here working, I think, with obslets of about 100,000 bytes. You are not sure that the memory manager will allow you to build an obslet of 10 million bytes without any interruption. And that's why they prefer. But again, it's a game of trial and error to find out what works best. Okay? So we have our program where we can start anywhere, and we have our program where we have to start at the beginning. The solution is simple. Make a big program where you can start anywhere, and at the end, put our shellcode where you have to start in the beginning. Then, if we land somewhere in the middle of that obslet, so a program that can be executed anywhere, it will start to execute and move on to the end. And at its last instruction, it will pass command to the following instruction, which is our shellcode that actually wants to achieve something. And that is what you see in this JavaScript. First element here is create a shellcode variable. This here creates a small obslet. 90 is the Xcode for no operation. Here in a loop, we make a very long obslet, so a set of instructions that do nothing. And then we commit about 102,000 blocks composed of an obslet followed by shellcode. And so we spray the memory with large obslets and small shellcode. And then 9 times out of 10, when this triggers, jumps to 32, 32, 32, 32, it lands on shellcode, that is the obslet, moves to the end, and then executes our shellcode. That is the final analysis that you want to obtain when you are analyzing malicious PDF documents. Find how they achieve to execute shellcode. Later on, you will also have to analyze the shellcode to see what it does. Most of the time, it will download a file, a Trojan, from a web server, write it to system32 and execute it, and that's it. That's what's commonly done in malware these days. But there are some other tricks they can do. We will look, especially because of the PDF format, and we will look into them in the next exercises. So I have no time, sorry now, to show this on a Windows machine, but if you install on a Windows XP machine, a virtual XP machine, that vulnerable version of Adobe Reader, and you open that file, then after a couple of minutes, you will have the exploit code that displays. Okay? It takes a couple of minutes because filling the memory, the heap spray, takes some time. Okay?
So how critical is the exploit? Is it a virus or is it just a...
No, my exploit, if I remember correctly, it launches calculator.
Okay.
It is.
So I can do it without risking my
Yeah.
machine. So.
Yeah, I've written that, and I'm not sure. I'm not 100% sure anymore, but I will check for you if I display a message box or if I run calculator.
Does not matter.
Yeah.
As long as my machine is safe.
Okay, now analyze exercise 13. Tell me what you find in exercise 13, in PDF file 13. There's something special about it. So exercise 13 contains an embedded file. In the new version of PDF ID that I've released today, it will tell you that it contains an embedded file. This one doesn't do that yet. Okay? Why am I talking about embedded files here in PDF documents? Well, we just arrived at a point where we understand how a PDF document can execute malicious code. How it can execute shell code. Shell code will do most of the time two things. One, download file from a server and run it, a Trojan. But the PDF document format also allows you to embed a file. So the shell code can also extract the embedded file and then write that Trojan to the disk and execute it, so that it doesn't have to contact a web server to download a Trojan, so it can operate more stealthily. The downside for malware authors is that they lose flexibility. Once it's in the wild, they have no control of it anymore. I mean, if they want to download the Trojan, they cannot change it anymore because it is embedded. While if it is hosted on a web server, they have control over it and they can change it over time. Take a look at object 8. And you see that object 8 is an embedded file. You can extract it in the following way. So you have object 8. You saw that it is compressed, so you have to apply the filter. And then you use option -D to extract it. and you give it a file name, file.exe for example. And with that command, you have extracted the file.exe from the PDF file. You could also do that with a PDF reader, but then you risk of infecting yourself, which is what we try to avoid with these tools here. So that is when PDF author uses the provided mechanisms to embed a PDF file in an arbitrary file into a PDF file. But it's also possible just to add the concatenate a PDF file at the end, and this will work too. And there is another way to detect and extract that. That's in the next exercise. Yeah.
Sorry, I had a look at Object 8 and I saw that it seems to be a file because type is embedded file.
Yeah.
But I saw no hint where to find the file or how.
The file is in Object 8. It is compressed. If you let me open exercise 13 here with the editor. So Object 8, it's an embedded file compressed with Flate, and here in the stream, a long stream, that's the file.
Okay.
Yeah.
See when you have an embedded file,
Yeah.
does that actually ever get written out to the disk? Or does it execute from the PDF?
No. First of all, embedded files, if there is no code or user interaction that touches the embedded files, nothing happens with them. For the file to be written to the desktop, for example, you need user interaction or JavaScript. And then, very important to know, is that all JavaScript readers PDF readers that support that will never allow you to extract executable files. They look to the extension, and if the extension is .exe, .vbs, .js, they will flat out refuse it.
Oh, but I could use some Whoosh extension. Could use some extension like TXT, but it's not.
Of course, but then you will not have automatic execution inside the Windows environment.
If it's .txt and it contains some JavaScript.
Yeah. The only language I found is Python. If you embed Python, they will allow you to extract that. So that's the stream here. Now, take a look at exercise 14. That looks pretty normal. But then run the same PDF ID command, but with option extra, -e. To have extra information, the -e. Do that. And then it will do a couple of extra calculations for you. For example, it will detect that after the last enter file, there can be several enter files inside a PDF document, because PDF documents can contain other PDF documents. After the last end of file, we are still finding 51,200 characters. And that is a clear example of a malware author who has just whacked his executable at the end of the PDF file. And that will work. The PDF parser has no problem with that because, it looks for end of file and everything that follows end of files is disregarded. Okay? Here is also calculations of entropy inside and outside of the stream. Inside of the stream you should find high and outside low. But this is an indication that we have another embedded file, but not properly embedded like the standard specifies it, but just by whacking it at the end of the file. After last 51,200. And you can extract that to PDF ID as an option -X that helps you extract that. So -X test.exe. It failed. Huh?
No, that's often -X.
That's not nice.
That does not like it.
Oh, I'm sorry. It's PDF parser. Yep. So with PDF parser, you extract the test exe from exercise 14.
Yeah, but it works.
Yeah. So that's another way that you often will find, because malware authors will just whack on the payload at the end of the file instead of using proper embedding techniques. Now, exercise 15 is also important to do. So do a PDF ID of exercise 15, because we're running late. We will stop with that last exercise. It's important to know this too. So run PDF ID on exercise 15. So you notice that there is no JavaScript, but that there is acroform. And let me open exercise 15 here. Doesn't seem. No, my reader. Oh yeah. Sorry, Foxit Reader doesn't support that. It's only Adobe Reader that supports it. But I don't like installing Adobe Reader on my main machine. So Acroform. Acroform is something special from Adobe, which is done to allow you to fill in forms. So if you get a PDF document that is a form, like a tax form, for example, and you have to fill in your name and complete all kind of data, well, there can be automation behind that, like input validation, calculations and stuff like that. You can do that with simple JavaScript, but Adobe has decided to add yet another set of features to do that, and that is called Acroform. And Acroform allows you to execute JavaScript. So this PDF file contains JavaScript inside the Acroform. So take a look at the Acroform with PDF Parser. Search for the Acroform. Sorry, this is exercise 15. And you see we have an Acroform in object 7. So take a look at object 7. There is the Acroform pointing to object 8, which contains the embedded file. Let's take a look. Minus W to make it a bit more clear. And here you see XML. Acroform is done in XML. And one of the things you can do in Acroform is script, a JavaScript, again, or alert message. Okay. So those are many different ways that PDF language allow you to start JavaScript, and from JavaScript on you can achieve compromising your machines. I'm going to stop now. Time is up. I hope you enjoyed these exercises, that they weren't too difficult but still a bit challenging. I will be here at Black Hat till Friday, so if you have a question or anything, just ask. And may I also ask you to complete the evaluation form? The survey. If you could do that for me, I would be very happy. Thank you.